What's up, people? St. Nicholas here. We did it. Parker is a brilliant engineer. So I'm going to try to break down his theory and what's actually going on in his transmitter and what my receiver is doing in my next presentation. It's very heavy engineering, mathematical. If you want to watch it, I encourage you to do so. It might be difficult to understand. I'll try to break it down right now in layman's terms, what we're doing though. Basically, Parker is generating at his transmitter a huge pulse, right? So once he generates this pulse, he sends it through his coils, and it goes up to the antenna, right, his dielectric antenna. But it's dielectric, meaning that it's insulated. It doesn't conduct electricity. So it's pretty much acting as a mirror, right? So it's reflecting the signal back down to the ground, at the same time creating a very low impedance from the ionosphere. So that low impedance is important because it establishes a nodal point for his transmitter. But basically, you're sending that signal down into the Earth, and this signal will go down to the center of the Earth. And once it's at the center of the Earth, it's similar to how a satellite will transmit from outer space to your TV receiver. So as long as you're tuned at the right frequency, no matter where you are on Earth, since you're at the center of the Earth, no matter where you are, it's going to connect. It'll be the same length. This transmitter should theoretically be able to transmit, across the globe anywhere, as long as you're grounded as long as your ground is 6 feet underground. But I love y'all. I appreciate you if you watch. If not, it's okay. Peace out. Alright, so this is the theory of seismic transmission. My name is Nicholas Matsoukas, or St. Nicholas. So our story starts with Michael Faraday. He was known as the grandfather of electricity, and he was the first person to visualize this ether, and he called it his lines of force. So you can see in this picture right here, we have a lot going on right now. Basically, this is what's formed. These fields right here, these are just iron fillets, but these fields are formed every time there's an electric current, and Faraday was kind of the first person to figure this out. And he called it there's a magnetic field and there's a dielectric field, but we'll go more into that later. So obviously we go to Tesla, and Tesla visualized this ether as an infinite sea of pressurized gas that permeates all space and matter. And he actually figured out how to manipulate this ether, and it turns out we can do just about anything with it, anything we want. So Tesla was using it as a medium to transmit electricity wirelessly, but there's other people, like if you know Wilhelm Reich is his name, he pretty much created the ether as a healing mechanism. He created these, he called it his orgone boxes, I think they're called, but he used orgonite to pretty much send you healing energy, and it turns out that it works. And there's been, documented cases of people getting healed from diseases miraculously by sitting in these boxes. But if you want to get familiar with electricity, you need to understand the concept of the ether. The ether is very important in electricity. Electricity cannot exist without the ether. So that brings us to Steinmetz, and I'm going to tell you guys right now, if you don't know who Steinmetz is, I mean, I didn't either, but Steinmetz is just as important as Tesla. He was actually hired by Edison, by General Electric, to crack Tesla's patents, because Tesla was creating all this crazy stuff, and no one knew what was going on. No one had any idea, and that's where Steinmetz came in. He broke down the math behind it, and there's a picture, I think it's on the next slide. Yeah, so check it out. So we have Steinmetz in the middle right here. He's the short little dwarf guy. He had a very bad condition. His dad actually wanted him euthanized. But you can see we have Einstein sitting next to him, and then look at that little guy behind him. You guys know who that is? That's your boy Tesla. So Steinmetz is in the center of the picture. He was very renowned in this world of electricity, but he's the reason why I definitely think that the government or whoever's running it, the powers that be, are very advanced, because as soon as he made this stuff engineerable, like the math was implying some crazy stuff. Him and Edison, I think it's the next slide, yeah. So here's him and Edison working in one of their labs, and there's rumors that Steinmetz and Edison were working on a phone to talk to the dead. They wanted to talk to dead people, okay? And his math was saying that all this is possible. So like I'm saying, who the hell knows what they have? But this was all in the early 1900s. They're probably at least 120 years more advanced than what they're telling us. So this brings me to Eric P. Dollard. Okay, Eric P. Dollard is my inspiration. He is probably the most knowledgeable person in electrical engineering to this day. All my research is based off of him. He's kind of the one who showed me Steinmetz and what Steinmetz was saying. He brought me into heavy side. He's the guy you need to look into, people, okay? Like, he's legit. He's been creating Tesla experiments since the 80s. He started off in RCA. That's Marconi's company, who ripped Tesla off. So he's in that world, and you know he's legit because Eric calls him the woman in white, but I think it's just the government he means. But his lab's gotten destroyed multiple times. He created a seismic earthquake detector, and they took it away. He could detect earthquakes by reading the seismology, the electrical readings in the ground. He could predict an earthquake, with 100% accuracy on where it's going to be and how strong it is based on electrical readings. So I really encourage you guys to check out his work, but most of my stuff that I'm citing is going to be Eric Dollard's, theories that he brought. He changed the world, honestly. He changed how we do mathematics. He showed that everything's possible with algebra. We don't need calculus to represent anything. So please go check him out if you're interested in this stuff. All right. So that brings us into electricity. Now, electrical induction is the way you need to think about it. So electricity is not electrons flowing through a wire. Sure, some of that happens, but it's an Einstein concept, and we need to get rid of that type of concept. So we need to think about electricity as unified fields. So think about it like this, right? So whenever you turn on a light, the electricity in that copper wire is not flowing within the copper wire. The electric and dielectric fields are doing work outside of the field. They're not pipe in a water in a pipe is a bad analogy because that's not what's going on, and it's very misleading. So this ether is what's creating this. You just pretty much have to distort the ether, and if you create the right conditions, this ether will create electrical induction. And all electrical induction is, when I say that, it's the product of the dielectric field and the magnetic field. And here's pretty much what it is visualized. So the little white dotted lines in the middle are the magnetic field. I'm sure most people have heard of that. And those circles, like the solid circles, are the dielectric field. So like I said, combined, those two are always present in an electric circuit, and you need both of those for electric induction. So that brings us to Parker and his brilliant piece of engineering. So what this is doing is it's utilizing this dielectric field. We're trying to harness the longitudinal waves. Now, modern electricity, it's based off of Maxwell's equations, who actually they're Oliver Heaviside's equations. Maxwell's equations were nonsense. They were just a bunch of math, and Heaviside simplified it. So that's electromagnetic theory. Pretty much all of electricity nowadays uses that theory. We don't use this longitudinal, this dielectric field, and that's a problem because we're missing out on half of electricity, we need to know the full picture and what's going on. It turns out there is a difference between dielectric energy, which is what Tesla is doing, and electromagnetic energy. The dielectric energy is it's almost as if you're creating a mini sun inside your light bulb, but we'll go into that later. So this is my hastily drawn picture. I'm an engineer, not an artist, people. So pay attention to what's going on right here. So we have the magnifying transformer. So we have this dielectric antenna. Dielectric meaning that it's not going to conduct electricity. It's going to pretty much repel everything. We have this Tesla coil right here. We'll get into that later. That's doing most of the work. We have a secondary coil, and we have a primary coil magnetically coupled together. This capacitor spark gap circuit is really important. This is where input comes in. This is grounded. So everything's going to the ground, and as you can see, we're going at pi/2 times the speed of light, and it goes in at velocity. It goes in at a cosecant angle, which is pretty much infinity. Obviously, that's impossible, but theoretically it is. Like I was saying, Tesla proved, I'll show that later, that everything's moving at pi/2 times the speed of light. So yeah, anyway, basically what's going on here is once you have this huge impulse, once you have this pi/2 times the speed of light wave, this longitudinal wave, this is going to get shot down to the center of the Earth. And once we're at the center of the Earth, think about it how a satellite will be able to transmit to a TV receiver. It's going to be the same type of concept. If the frequencies are in tune with each other, so if I have a receiver coil that's grounded at least 6 feet in the ground, since the signal's at the center of the Earth, it doesn't matter where on Earth you are, the distance is going to be the same, so you're going to be able to pick up on that frequency. So no matter where you are, you'll be able to receive this wireless electricity. And another thing I wanted to talk about, I know some people are wondering, well, isn't the ground going to get in the way? Isn't there going to be metal poles? And is it going to disturb the radio frequency of the world? The answer is no. So first of all, to address the statement that it will interfere with the world's radio frequency, it will not, because again, all of this is going on underground, where everything else is transmitted above ground. We are not in the way, and even if we were above ground, we're not going to be in the way. Think about it. There are multiple frequencies going on every day in our life. There's a plane flying overhead that's using radio at a frequency. There's a guy with a ham radio using a frequency. Your cars are using radio. There's radio waves everywhere, and they never interfere with each other. This is no different, okay? Anyone who says that is just probably a fear-mongering puppet. So don't listen to Neil deGrasse Tyson. He's a rat, okay? Anyone who defames the stuff and says it'll get in the way is controlled opposition. They're rats, and don't listen to them. This technology will work. So the reason why it will be able to transmit through the Earth is, I'll get into this later, you'll see. But mathematically, the longitudinal wave is in counterspace. So there is no time dimension. There's only a length dimension. So pretty much it means that it will be, as long as you're in tune, you're going to be instantly be able to receive the signal, because we're in counterspace. So breaking down this spark gap. Now, the spark gap is very important because it creates a break in the circuit. So Parker was saying he has a 7.2 kilovolt AC circuit. So we're sending that in, right? And pretty much how this is going to work is, once the potential reaches a maximum in the spark gap, it's going to break, right? So think about it like you're hitting like a punching bag, but like you're a boxer, right? And you're punching a bag, and when you punch it, right, momentum's going to swing it forward and back, right? And pretty much what this is doing is, every time you punch the bag, when it's on its way back, you're using the momentum for its maximum swing, and that's pretty much what the spark gap's doing. So you send that through the capacitor bank. Those are what Parker's little buckets in his glass bottles are. Those are capacitors, and you send that to the primary circuit. And he was saying that he needs 5 nanofarads of capacitance. So here we go. We got this dielectric antenna. The red coil is the extra coil, or referred to as the Tesla coil. You can't really see the primary coil in this one. I'll show it on the next slide, but the secondary one is the big one around it, and then this little transformer here is this high voltage 7.2 kilovolt input. And you can kind of see the primary coil a little bit better now. It's the thicker wire on the bottom. The primary coil is only wounded a few times because it has a high impedance, so you need a thicker wire. But this spark gap, you can kind of see it. It's right here. He has a motor that's powering it. That's, again, going to be the break in the circuit. And then these little bottles right here are the capacitor bank. So this is just a comparison to Tesla's Colorado Springs lab. Pretty similar setup. Tesla was using, again, Leyden jar as capacitors. He's got a spark gap over here. This is a secondary winding. You can't really see the primary extra coil from here. He's got his transformers up here. Like I said, very similar setup. So again, we're going to need a big energy pulse to discharge the spark gap to the capacitor bank. This energy pulse needs to have the greatest possible energy with the lowest practical impedance. So there needs to be no resistance, right? We need that energy to flow without any resistance getting in the way. And the spark gap is going to let us do that, because the buildup of energy happens, and once, like I was saying, once it reaches its maximum potential, it's going to discharge. So the primary coil receives this impulse from the spark gap, and when the potential in the spark gap is the highest, the primary coil is the lowest. So once the primary coil reaches its lowest potential, the spark gap will send another impulse through. And then, yeah, pretty much the voltage from the primary goes to the secondary and extra coils. We'll get more into that later. Yeah, so the secondary and Tesla coils are just used as transmission. Like I said, they're pretty much building up the momentum of that impulse right there. Once everything's built up, so Tesla's saying that once you have your pulse in the Tesla coil or the extra coil, you're going at pi over 2 times the speed of light right there. So that extra coil is doing a lot of work. So Eric Dollard was saying there's a way to eliminate the primary and secondary coils and only use the extra coil for more magnification. I haven't figured out a way to do that yet, but I'll have to look more into it. So the dielectric antenna is really important. So most people think of the antenna as something that transmits, right? But this is not what we're doing in our case. The normal radio wave, yeah, sure, it transmits, but this is set up differently. Tesla created his devices to send into the ground. Marconi took these devices and he's like, oh wait, we're going to send energy into the air. I'm an idiot. But that's not what Tesla wanted to do, because these Hertzian waves, the way that radio works, it's very inefficient. So the dielectric antenna pretty much, it has two purposes. So you're pretty much just reflecting that impulse back into there. So it's just like a mirror pretty much, right? So it just goes up to the antenna and then back down into the earth. So the dielectric antenna also creates a low impedance in the ionosphere. So this will establish the magnifying transmitter as a nodal point. Pretty much what that means is when I put my receiver coil and I connect it and I tune it, it's going to make tuning it, and they're gonna connect a lot easier because of this low impedance in the ionosphere. Nothing else is going to be a low impedance, so that's how the frequencies know how to talk to each other, because of this low impedance. It's really important. So I pulled up Tesla's patent. You can look it up yourself. He called it his electrical transmission through a natural medium. He states again that the extra coil is doing most of the work and the primary and secondary necessary evils. He states in his patent, I believe it's on the next slide, that it's this number right here, about 471,240 kilometers per second, or about pi over 2 times the speed of light. I've heard that number oscillates a little bit, but it's approximately about pi over 2 times the speed of light. So now we need to get into the longitudinal waves. Like I was saying on my last video, when you have a coil wound up like that, so we're going to think of the primary, secondary, and extra coils as a one oscillation system. Now, you can see how the transverse follows the winding of the coils, and that's where that wave forms. The longitudinal wave forms within that coil parallel to, the direction of where the current's flowing. And like I was saying before, these longitudinal waves are what we're taking advantage of, what Parker's doing, how we're able to do this. And it just shows the resultant right there. So you can utilize the math. You can engineer in a certain way to get the resultant. Again, we don't want that. The way this is set up, we're only using these longitudinal waves. So this is just a better way to visualize it. So it's pretty much just like a sound energy. That's a longitudinal wave. But think about like a slinky, right? Where if you have a slinky and one end of the slinky is in both hands, right? And you're moving it back and forth, the little wave that moves is a longitudinal wave. So what's really cool about these longitudinal waves is they're a superposition of the dielectric and magnetic fields, so you just combine them. And they're not measured in velocity. They represent waves in counterspace, or if you want to go in physics talk, it's another dimension. So it's going to be a complex solution pretty much, meaning that when you take the square root of -1, this is going to represent our longitudinal waves. But the term imaginary is obsolete. It doesn't make sense because it's there. It has to be there. The math shows it. So if it's not in our world, it's in another world. And in math, you represent this as 1 over cm, 1 over centimeters, or centimeter to the -1st power. And this is just sort of a visual representation of what counterspace looks like. It's just space within space, if that makes sense. It's really hard to explain, but you'll just have to. You're just in another dimension, pretty much. You're within space. You're within the space of the ether. So now I'm going to show you guys what's going on inside of this coil. Again, you need to think of it as just an oscillating system. All the coils are combined. It does not operate as a normal circuit would operate. So let's take a look at what's going on here. So this is the equivalent circuit. Obviously this isn't what's happening, but this is the representation of it. So we've got going this way, so going, I don't even know how to say that, but going this way on the circuit, it's a transverse path. So those are going to be your real waves, and going downwards this way is going to be your longitudinal waves. So we need to pay attention to these coefficients right here, right? So C is going to be the coefficient of dielectric induction. It's going to be transverse to the direction of propagation, and it's going to be measured in farads over centimeters. K is going to be the longitudinal component of this dielectric induction. It's going to be measured in farads per meters. Again, check that out. This is going to be the counterspace representation since it's per unit. L is going to be the coefficient of the magnetic induction, L over centimeters. That's henries over centimeters, by the way. That's what a coil is. It's going to be transverse. And we have M finally, which is the coefficient of magnetic induction, which again is counterspace, L over centimeters. And this is going to be longitudinal. So pay attention to this formula, people, okay? I'm not going to derive it. I'm not going to go into it. Maybe I will in another video. There's a lot of math involved, but this is what the formula turns out to be. So pay attention. W, or omega, is 2 pi f. That's in radians per second. It's how you represent the frequency. But this is the magical equation, okay? So notice how we have a fourth root, right? It's a fourth order complex differential equation, and this whole thing represents what's going on inside of the coils. And if you take a look, this equation is very similar. It's almost the same as Oliver Heaviside's telegraph equation. Oliver Heaviside was the guy who pretty much saved the people who were working on the telegraph. I forgot who they were. I forgot their name, but they couldn't figure it out. They're getting a lot of blockage in their signal, and he pretty much came and whipped up the math and said, hey guys, this is how you do it, and sure enough, it worked. So sure enough, it works the same way in this system right here. Now, what's really important is pay attention to this fourth root. Electricity needs to be represented as a four-phase or four-arch system. So since we have a fourth root, we're going to have four solutions. So we have 1, -1, J, -J. Again, these negative J's are very important because they represent counterspace, or another dimension. So that's pretty much it. Obviously, like I said, I can go a lot more into this, but I just wanted to make sort of a layman's type of thing. I didn't want to go too in depth. I don't know what people want, or this, because this is my first lecture. So I can go way more into the math if people want it, but this was just pretty much, because we had a successful, caloric transmission, and I want people to know kind of what's going on. All right, anyway, thank you so much to Parker for making all this possible. You're the man, dude. He's a freaking genius, man. The way, I would have never... I've taken 4 years of electrical engineering, and I've learned more shit from him than school has taught me. So, he's the man. I'm sure all you know that. Please subscribe to me at St. Nicholas on YouTube. I'm going to be making a lot more lectures, videos like this on this sort of stuff, on the ether and counterspace and how to use these physics to your advantage. And here's my acknowledgements. So if you made it this far, thanks for watching. I appreciate you. Please subscribe. I love y'all.